Okay, everyone, let's start this content for chapter 2, supply and demand. I'm going to try to just record this one in one go and then split it up into the four parts. So hopefully this should work pretty seamlessly. But um, yeah, again, never have done this before, so we're just going to kind of keep going. If you wanted to follow along with the textbook, I would highly recommend that you follow along with the textbook. Again, we are going to be skipping over section 2.7, I think it is, the one that is talking briefly about quantity supplied is not equal to quantity um, demanded. That's just going to be kind of like I'll talk a little bit about the invisible hand, but for the most part, that's going to just kind of be pretty straightforward. And we're going to get a little bit into price floors and ceilings, but you should have covered that in principles. Um, there's nothing really more that we can add with our new lens in this. So yeah, why don't we just get started with section 1. So this is going to be the first video. We're going to be covering sections 2.1 and 2.2, which are supply and demand. Um, and so, yeah, we're going to just start here with, in this chapter, we're going to focus on 8 things, right? So the first one, demand, is the quantity of a good or service that consumers demand depending on price and other factors, such as consumers' incomes and the prices of related goods. Supply, the quantity of a good or service that firms supply depends on their price and other factors, such as the cost of inputs and firms, right? It's the general supply and demand that we normally have, all sorts of good stuff. So yeah, why don't we just start with 2.1? So here are a couple definitions from demand that we have. Quantity demanded, again, is the amount of good that an individuals want to buy during a given period at a given price, holding all other factors constant. And this term right here, this all other factors constant, is kind of important when we're dealing with this. What this means is that there may be a bunch of other inputs that influence the ability of like quantity demanded, right? So it could be something like information, different tastes. I might like grilled cheese. My brother might like quesadillas. We're still going to have a demand for grilled cheese. He just may have less. Similarly, information about the goods. Maybe I know that grilled cheeses is better for me than quesadillas because it has more butter, whatever, or the opposite, I guess. Prices of other goods, maybe quesadillas are cheaper, people's incomes, maybe I just have more money and I can spend more money on this. There's also government rules and regulations, timing, fads, all sorts of stuff. We're going to pretend when we say holding all other factors constant that all of those extracurriculars on the end are just constant. They're not moving, they're not changing. The only thing that we're going to let change is the price of our good to see how the demand changes as well. Then we have this demand function that says the relationship between quantity demanded, and we're going to call quantity demanded this QD because it stands for quantity underscore demanded, and price P, keeping the other factors constant again. And then there's this thing called the law of demand. And the law of demand says that the relationship between quantity demanded and the price will be negative, which is pretty straightforward, right? The more that something costs, the less that I'm going to want of it. If something costs $100 per unit, depending on what, like, let's say ramen noodles we're dealing with, right? At $1, I'm probably going to demand a lot. I can buy a lot. But if ramen noodles were $10 a cup of noodles, then I'm not going to drink that, or I'm not going to buy that as at all. I'm going to look for something else. Um, so now we get into like let's throw a mathematical formula on this. And so this is what we're going to call the demand curve. This is an implicit function for a demand curve. The way that you would read this is that you would say that um, quantity demanded is equal to some function d, which we're going to call our demand function. And our demand function is a function of our own price, so the price of the good, the price of substitutes, the price of complements, and our income y, right? And so our income is just our budget constraint. It's typically denoted as y, but there's really nothing that we can do. Like, I mean, there's nothing that says that it has to be denoted as y, um, like that. But yeah, we're gonna call this our demand curve, our implicit form of our demand curve. And so, if we wanted to move in away from an implicit to an explicit form, we could add any sort of functional form. Let's just assume for simplicity that these guys are additively separable, which means that we can add them together or subtract them together. And so our implicit functional form would say that we have some base level of quantity demanded, and then we have this effect that is going to be directly related to the own price, the effect that is going to be directly related to the price of substitutes, the effect that is related to the price of complements, and this income effect. And again, when we're saying holding all things constant when we do things, we're going to be holding this back half constant. So essentially, we're going to set certain things, like let's say that PS is equal to 1, PC is equal to 1, and Y is equal to 15. You would substitute each of those in, and then the only thing that would be allowed to move is this P here. And so holding all other things constant is just a fancy way of saying, like, let's make all of these fixed. And so there's some intuition behind these signs, right? The law of demand says that as price increases, quantity decreases. As things get more expensive, things are more expensive, I want less of them. We notice that here by this minus sign. Similarly, the price of substitutes, which would say that our price of something that we would exchange for. So let's use an example here of coffee, right? So let's say that our Q here is the quantity of coffee demanded. And this price is the price of coffee. This price of a substitute is going to be a price of tea. And a substitute is some other good that we would consume instead of coffee. And so if we wanted a different good, we would look for tea, maybe we would look for matcha, a chai, something. And then we've got this price, this complement price. A lot of people like lattes, so maybe we do this is the price of milk or sugar. And then again, this is our income. And so if we think about what happens if the price of substitutes increase, well, by the law of demand for the other good, so let's say that the price of tea increases relative to our price of coffee, the quantity demanded of tea is going to decrease. So our quantity demanded of coffee should increase. It gets more expensive to do the alternative, so we're just going to take what we normally went for. Similarly, if the price of our complement increases, so the price of milk becomes more expensive, chances are that this price of coffee, it may stay the same, but the price of our latte might get more expensive. And so if we only drink coffee through lattes and we have the price of a different input of this function of this good starting to increase, we're going to want less of that because it's going to be more expensive. And lastly, we have this income increases. If we can buy more goods, we're going to buy more goods, right? We're always going to assume that we're going to probably buy everything that we can with this. So if you want to think of this as income to spend on coffee, that would be another way to think about it, right? Like, obviously, there are other things that we have to spend on, right? If we get a huge bonus of $250, we're not probably not going to spend all of that on coffee in reality, but we're going to assume that these are in reality. Like, we're going to assume that we're going to spend it all on coffee. And so that's kind of the intuition of the science. When we're thinking about how demand and supply changes, this is a pretty simple way to do it, but this is going to be kind of the key when we're thinking about comparative statics. And we're going to get to comparative statics in a bit. But this is something that you should keep in mind is like, how do different things interact with each other and influence each other? And so let's imagine that we were constructing a demand curve, right? So consider this curve. It's going to be our quantity demanded times is equal to 40 minus 20 times the price, right? What's our slope in this instance? Well, here, our slope would just be the constant in front of P. So our slope in this instance would be minus 20, right? Um, Kind of, right? Another way to think about this is we could think about this as dq dp, right? And that would indeed be 20, minus 20. But what's the problem here with how this is constructed? We want, when we're dealing with demand, we want downward sloping demand. And so the other thing that we want is when we construct these demand curves, we typically throw price on the y-axis and quantity on, or sorry, opposite directions. We typically want this to look in a certain way, right? And so when we do this, we should rewrite in our inverse form. Yeah, so we want price on the y-axis and quantity on the x-axis. And so if we want price on the x-axis, I mean on the y-axis, we want to rearrange this equation here so that we have a function p is equal to something, right? So we're going to go q minus 40 divided by negative 20. And so our new our new function is going to be price is equal to 2 minus 120q. right? And so we're going to have this downward sloping demand like this, right? Where this is going to be at 2, and we are going to be at 0 when we reach 40, right? Those are going to be the key things that we're going to want to do when we're constructing a demand curve. So when we're graphing and we're thinking of all of these things, a lot of times the math is easier when we have quantity on the left-hand side, right? We're going to be doing a lot of things with quantity demanded and quantity supplied. And so we want to make sure that we can combine those two to find equilibria, which we'll get to in a second. But we're going to definitely want to make sure that we know exactly how these are changing. And more interestingly, is that when we're thinking about slopes and derivatives and marginal returns, we want to make sure that our choice variable, or this x variable, is always in the bottom. So our slope that is more of interest should be this minus 1/20th. Um, Now let's pivot a little bit to supply, right? Because supply is going to be slightly different, but it's going to be pretty similar. Quantity supplied is the amount of good that firms want to sell during a given period at a given price, holding all other things constant. The supply function is keeping the relationship between quantity supplied, QS, and price, holding all of the factors constant. But here, if you notice, that there's going to be no real difference. I mean, there is no such thing as a law of supply, right? And so when we're thinking about the law of supply, I mean, the law of demand, it says that our demand has to be downward sloping. There is nothing that says that our supply has to be upward sloping. There's nothing that says that our supply has to be couldn't be flat or even negative sloping. And so there's a lot of things that could cause the supply curve to shift and be it in whatever direction we want. Um, but yeah, for the most part, the supply, there is no law of supply. And so thinking about this again, we have this supply curve, right? So we're going to want this quantity supplied here to be a function of our supply and our own price, P, and the price of complements, C. And again, when we're thinking about supply or thinking back to demand and our translation to supply, you might be thinking like, well, wait, we had this price of substitutes beforehand. Where's the price of substitutes here? Or where's income here? We could, in theory, throw a budget at the end, like a B. We can only spend so much money because we only have so much money. But we really don't care about the price of substitutes. Our price of, like, it doesn't influence, like, if we were a company and we are a coffee producing company, we're Starbucks, let's say, and let's say that Starbucks doesn't sell tea. Um, we are going to be sending all sorts of things the other direction. Um, when we were thinking more so, only about the inputs to our functions, right? So we're only going to be caring about the price of coffee and the price of sugar and milk, right? We don't really care about the price of tea because we're just trying to make as much as we can at whatever direction. Okay, so if we do this in explicit form, right, we're going to get the same thing. But if you notice, our signs kind of differ, like our intuition behind the signs. So if we recall from demand, as price increased, quantity demanded decreases. But as price increases for quantity supplied, our quantity supplied should also increase because we're going to be able to generate more goods the more that people will pay for it. Alternatively, the more that our input costs increase, the more that the milk happens, right? So the more that PC increases, right? So if PC increases, the more that we're going to be able to make decreases, right? So the more the lattes that we're going to be able to make if we're only coffee bean roastery and we need to import our milk, if milk becomes more expensive, we're not going to be able to do anything with it, right? So let's look at an example with this, or I guess there's a little bit more intuition here. Sorry, I don't really know my own slides. Maybe I should pull it up on the second monitor here so that I can kind of stay ahead of the game. Um, an increase in the price leads to an increase in quantity supplied, but an increase in the price of a complement or like another input leads to a decrease in quantity supplied. So that's kind of exactly what we wanted to think of here. So let's look at a specific example. Let's think about constructing a supply curve here. While we have this supply curve, the same thing that we had from above, right? Let's fix or holding the price of a complement constant, right? So let's say that this is a 9.6 plus 0.5p minus 0.2 times 3. So 9.6 plus 0.5p minus 0.6. Those are going to combine to give us our quantity supplied, right? And typically you'll see if we're dealing with quantity demanded and quantity supplied, those will be subscript, so you'll know what the difference is. But for the most part, if we're just dealing with one of them, the Q just means quantity. Um, and so when we're thinking about this more, right, that's pretty much the supply curve, right? Just like in the demand curve, we're going to want to think about this. And if we think about this now, right, thinking about the demand curve instead, thinking about the supply curve, we have price on the Y, quantity on the X, right? Let's flip this. So we are going to get P, 0.5P, should equal QS minus 9, divide everything by P, that means by 0.5. So we are going to get 2QS minus 18, right? Because when we're dividing by 0.5, it's the same thing as multiplying by 2. So we are going to be all the way down here at negative 18, right? But our quantity supplied is going to be an upward sloping line. And so really, you wouldn't see this part that's under here. This would be all blacked out. And we would just see that this quantity supply curve looks up like this. So if we started this from just here, it would be fine. And then we would have our quantity demanded on this side, right? So if this was D and this was S, then we would be able to find the market clearing condition there, right? And so that's supply and demand right there. That is it. That is what we need most part. We're going to learn how to play with this a bit, but that is quantity demanded, right? And so let's think about this, right? Let's think a little bit more on supply. So what happens if the price of our complement increased from $3 to $6? So if we remember, our original quantity function was 9.6 plus 0.5p minus 0.2 PC. Our quantity 1, let's call, when PC was equal to 3, was our definition here. But when we change this to be 6 instead of 3, so PC should equal 6, then our second quantity should be like 8.4 plus 0.5p, right? So we should be looking at this curve and this curve, right? And so that's exactly what we see. We see Q dot and Q. What does this do when we graph this? So if we're graphing this, right, remember, this P was 2Q minus 18. This P should equal 2Q minus whatever 2 times 8.4 is. So 16.8. Then we're going to have a curve, a supply curve that looks like this. And then we are going to have a supply curve that shifts in. So this would be Q, or I guess this would be S1, and this would be S2, right? And so we would shift left. So one thing to note is that when we are doing kind of larger shifts, right? Or another big thing, right? So a $3 increase in the price is going to shift things to the left, right? So let's say that we had our equilibrium value here, right? Let's say that this was 2, and this it was, to begin with, 10, right? If we throw in a, and then if we wanted to see the $3 increase, right, then we are going to see this shift here. Actually, I don't think this is the equilibrium. I think this is close to the equilibrium, but I don't think this is the equilibrium. But if we just say this for the sake of argument, that this was 10, and then this was like 9.4 or something, then that would be the equivalent of the shift. We'll get this exact mathematical thing here in a second, but that would be our shift in supply. And so one thing to notice is that when we're dealing with the price of a complement or something else changing, we see an entire shift in the curve, right? We see the curve move from S1 to S2. If we were only looking at a change in the price, so here, let's add our labels to this. Sorry, that's me being sloppy. If we were only looking at the change in a price of P, right? So let's say that P increases, we would just move up the curve. If this wants to stay, we would just move up the curve. So it would be to here, right? And so that's going to be kind of the big difference between the two, is that if the price in the good in question moves, we just move along the curve. But if a price of something else changes, that means that we are going to shift the entire curve. And so we're going to shift to make sure that everything is usable and that we are adjusting correctly. And so now let's start thinking a little bit bigger, right? So we've got these things, right? Typically, it's not just me that is existing in the market, right? Typically, we're going to be thinking of lots of people existing in the market, right? So let's say that my neighbor, Sam, and I are both existing and we both have a demand for coffee, right? So then let's say that this is mine, Ian's, and then let's say that this is Sam's. One of the big things that we're going to be doing is that we're going to make sure that we want to that we can keep things the same across everything. And we want to be able to look at things in aggregate or all together. So the total quantity demanded at any given price is just the sum of the quantities that each consumer demands at that price, right? And so Q1 is equal to D1 and Q2 is equal to D2. Total quantity is just going to be D1 plus D2 or Q1 plus 2Q. And the way that we're going to do this is we're going to first find the intercepts of both. Two, sum the quantities across. And then three, if the supply curve, if the price intercept is the same, we're going to draw the demand curve. So let's think about an example in this way. So let's say that this first one is my demand. So this is Ian's. And this one is Sam's. So step one was that we wanted to find the intercepts. So first, let's just say Q1 is equal to 0. Well, that occurs when price is equal to 120. So we have a point 0, 120 that is an intercept. Similarly, when price is equal to 0, that means that our quantity demanded is also equal to 120. And so we are going to have another intercept that looks like that. Similarly, across here, if Q2 is equal to 0, then our price is going to equal 120. No, sorry, our price is not going to equal 120. No, yeah, our price is going to equal 120. Sorry, my fault. And if Q2 is equal, or if price is equal to 0, wow, then Q2 is going to equal 60. Right? And so what we can do is we found the intercepts, right? Let's plot both of these, right? So we are going to have, we'll make mine pink and Sam's will be blue. So we are going to remember price goes on the y-axis, quantity on the x. We are going to have a point here at 120 and a point here at 120. And for me, that's going to be my demand. Similarly, we're going to have a price up here at 120, but our quantity is going to be 60 down here for Sam. He just doesn't like coffee nearly as much as I do. So when we're thinking about this, now, what do we do if we want this in aggregate? So, right, what do we want to think about if we want to put these both together? Well, we can very simply just take Q1 plus Q2, right? If we wanted to say that this was like Q total. Right? And so we're going to take 120 minus P. And we're just going to add 60 minus 0.5p, right? And notice that because our price intercept is the same, we should be able to just sum these two together because one of us is not going to be priced out of the market. Now, suppose that Sam's demand was not like he wouldn't be willing to pay more than $100 for something. As soon as he hits $100 here, his demand is going to turn off. And so we're just going to jump immediately back up to mine, right? But since we have this here, we'll be fine. And so we're going to go 180 minus 1.5p, right? And so this would be Q total. So at 0, quantity demanded, we are going to be at whatever 180 over 1.5 is. That should be 120 again. And then if we wanted price to equal 0, well, then Q is going to be 180. Right, so I guess let's just adjust our graph just a bit. Oops. Let's make this 120 and this 180. And then we'll draw mine again. And then we'll draw the total. Right? But again, let's say that Sam's was like he turned off here, right? We would just follow this green line. It would look something like this. Here, we'll do it in orange instead. It would look something like this, where there would be a kink beyond. If there would like our price intercept was not the same. And so there would be a kink if we disagreed on the price. But since we don't disagree on the price, we don't need to worry about that. We can just keep this as the cleaner version of everything. Okay. And so that would be the summation of the demand curves. That's going to wrap up supply and demand. In the next video, we're going to be talking about um, shocks to the equilibrium, I think, and market equilibrium. So we're going to try to combine supply and demand together to get into shocks and equilibria. Thanks.